Okay, students, I am very happy to take this small topic today. This comes in logics and proofs, or logics and proofs. Okay, one of the important problem is about this one. Two logical statement will be given. This is one logical statement, and this is the another logical statement. We have to prove that both of them are equivalent. We say logically equivalent. That's what we have to prove here by using the truth table. By using the truth table, we have to show that both of them are equal. Now we must use the truth table formula here. The truth table formula, first we are taking as P, and the possible combinations are true, true, false, false, and Q. Its possible outcome are true, false, true, false. Okay, this is possible outcome for P, and this is possible outcome of P. This is possible outcome of Q. Now we are finding out negation of P. That's what, because we need here negation of P, so we are finding out negation of P here. Negation of P is nothing but the opposite truth value of P here. So if the truth value of P is true, then it is false. If truth value of P is true, then its value is false. I mean, the negation of P is false. If truth value of P is false, then its negation is true. If the truth value of P is false, then its negation is true. Okay, so these are the negation of these. Okay, now let us find out the two statements given here. The first statement is this, and the second statement is this. Let us find one by one. Let us find out this first, afterwards this. So to find out this, look at this. This is negation P, and Q is here. Okay, so negation P is here, and Q is here. Now negation P are with Q. Are with Q. The formula says that if this is false, this is true, then we have negation of P or Q is true. Okay, that's what the formula says. Okay, so if negation P is false and then Q is false, then we have false. Okay, then the formula says that if the negation P is true and Q is true, then the truth value is true. And last chance, if the negation of P is true and the Q is false, then we are applying our formula, the final result is true. Okay, so thus we can find out the truth values of negation P or Q. Negation P or Q we can find out. Now let us find this formula: if P then Q, if P then Q. So this if P then Q, this particular symbol or operations, or we say connectives, have some formulas. Okay, now if P is true, Q is true, then P implies Q is true. If P is true and Q is false, then P implies Q is false. If P is false and Q is true, then P implies Q is false. If P is false and Q is true, then F implies F, false implies false, is true. Okay, that is what if and only if formula. So by applying if and only if formula between P and Q, that is this combinations and these combinations, then we have these truth values. Now compare both of them, that is this statement and this logical statement. Okay, so if the combinations are equal, then the truth values are equal. Look at that. If true, true, then the truth value of both of them are equal. If first one is true, second one is false, then the truth value of both the statements are false. If this is false, this is true, and then the truth value of both the statements are true. If the truth value of both of them are false, then you look at that, the truth value of both of them are true. So the statement, truth value of this statement and these statements for different combinations are equal. Therefore the two statements are logically equivalent. That's what they say. So two logical statements are equal if their truth values are equal for different combinations. That's what we are seeing here. Okay, thank you. Okay, thank you very much, students. In today's class I will take some problems connected with problems which is not. Now look at that. This is in 2010 November in the Anna University. This question is appearing. Now let us take this, and we have to prove this by not using truth table. So many questions are asked where we should not use truth table to find the answer for the given problem. Now what we have to prove in this problem is that P implies and implied by Q is equivalent to P and Q are negation P and negation Q. That is what we have to prove. That is, you take this as a left hand side and this as right hand side. We have to prove that this left hand side is equals the right hand side. That is what we have to prove. Now let us find out the solution for that. Now take left hand side here, that is P implies and implied by Q, and this is exactly equal to this, that is P implies Q and Q implies P. That is, if you find out the truth value of this, the truth value of this would be equal to the truth value of this, that is P implies Q and Q implies P. Now the another formula is that P implies Q is equivalent to negation P or Q. Similarly, Q implies P, we can write it as negation Q or P, because there is an equivalence formula like that. Therefore P implies Q and Q implies P would be exactly equivalent to negation P or Q and negation Q or P. Now look at that here. This is exactly equivalent to this one, that is negation P and negation Q or negation P and P. That is, distributive law is used here, negation P and negation Q. That's what we have here. Then this R will come here, then negation P and P. That is what we have, negation P and P. Similarly, we can use the distributive formula here, Q and negation Q, Q and negation Q, and next one, Q and negation P, Q and negation P. So we can use the distributive formula here to get this expression from here to here. Now look at that, negation P and negation Q are negation P and negation Q, because here negation P and P and Q and negation Q, these two are tautology. So tautology is equal to tautology. Tautology into this formula will be equal to this formula. Okay, so we get the answer as P implies and implied by Q is exactly equivalent to P and Q are negation P and negation Q. This type of problem would be asked in the university questions. We should not use the truth table to prove one equivalence formula is exactly equal to another logical formula. That's what we have seen in this class. Thank you. Okay, thank you, students. In this session, I am going to prove this small problem. Okay, and you must see that this type of problem will be asked prove without using the truth table. That's what in the university question they would ask. Okay, use not truth table, prove this. That's what they will say. So take for example this problem. This is left hand side, this is right hand side. So left hand side equals the right hand side. That's what we have to prove. Now let us take this left hand side first. Okay, so left hand side we are taking, that is P implies Q and R implies Q. Now this equation can be written like this. How? By using this formula, P implies Q is exactly equivalent to negation P or Q. So inside the bracket, use this particular idea. P implies Q can be written as negation P or Q, and this and you are writing as it is. This R implies Q becomes negation R or Q. You will get by using this formula. Now how we are getting this step from this? Now negation P R Q and negation R Q. So we can use here the distributive law. Okay, Q is common and this R is also common. We can take it out. Q is common, R is common, outside it take. Now negation P is here and negation R is here. So this big expression is exactly equal to this expression. Okay, if you expand this, you will get this, or if you shorten this, you will get this by using distribution law. Now from this, look at the first bracket, negation P and negation R. We can use here De Morgan's law. So from here, the first bracket will become this first term here by using De Morgan's law. Negation P and negation R is exactly equal to negation of P and R by using De Morgan's law, and the next terms are coming as it is. RQ comes here. Now look at this negation of P or R or Q. Look at this particular formula from right to left. Negation P or Q would be exactly equivalent to P implies Q. So from right hand side to left hand side, like that here, negation of PRR RQ is exactly equivalent to here that PRR implies Q. That is negation PRR RQ. By using this particular idea from left hand side to right hand side, we'll get PRR implies Q. So thus this is what the right hand side. Look at this right hand side. So we have taken the left hand side, applied the formulas, distribution formula, De Morgan's law, and this formula to get the right hand side. This type of problems will be asked in the university question now and then. The term that they would be using is that without using truth table. That is the word they will use. That means equivalence formula we have to use, and we have to prove that the left hand side equals right hand side. This way of problem is very, very important. So in another session I will take another problem. Thank you.